we're going to try some examples. The following three charges are arranged as shown. Determine the net force acting on the charge on the far right. So what is the net force on this one? So what we're going to have to do is calculate the force between one pair and then the next pair until you've calculated all the possible combinations for the question. If you've calculated the force Q1 on Q2, you also know Q2 on Q1. So that's just some of Newton's laws there. Okay, charge on 1 and 3. So the electrical force equals K Q1 Q2 R2. So we're going to take our K value, which is a constant. We're going to multiply it by the charge of particle 1, 1.5 times 10 to the negative 7. And then we're going to take the charge on particle, the second particle, which we're taking is this one right here, because we're doing 1 and 3. So negative 3.5 times 10 to the negative 4 coulombs. And how far apart are those? Well, they're 1.4 plus 1.7. So they're a grand total apart of 3.1 meters. Okay, we're going to square this, and this is the force we get. Now we have to look here. We have a positive charge and a negative charge. Positive and negative, they're going to attract one another. So Q3 is pulled towards Q1, or to the left. Now we're going to look charge 2 and charge 3. So now what is this guy causing this particle to do? So we're going to use Fe again. And be sure to pause this video, scroll, make sure you understand what's going on, and ask me questions if you don't. K Q1 Q2 over R squared. So we take our K value, which is a constant. The first particle, its charge is 2.3 times 10 to the negative 7. Its second particle is 3.5 times 10 to the negative 4. And the space between it is 1.7. When I calculate this out, I get 0.25 and some change newtons. These two particles are both negative. Because they're both negative, they're going to repel. So this force is to the right. So now we add the forces. Okay, so this guy right here is being pushed to the right by particle 2, but pulled to the left by particle 1. So we're adding two vectors together. So that's what I have here, how it's being pulled to the left and pushed to the right. I add those together, I get a positive value that tells me it's to the right. Okay, so we have to pull in some of our vector addition. And these were all along the same plane, so you can kind of guess where we're going to go next. We're going to go when we're adding things not on the same plane, when they're going to be in triangles. Okay, and we're going to have to find x and y components. That's where we're going with this.